Good Friday to you guys. How are you doing? I am obviously out of the building today, so you are getting a video lesson. This is a lesson on 15.2, constructing arithmetic sequences. We're going to build off of our knowledge of what we talked about last class we talked about how to come up with the explicit and recursive rules for geometric sequences. And now we're going to use those in tables. We're going to find out how we can take those and take away some in-between numbers and still find out what the common difference is, or the common ratios in this case. And then we're going to apply it to a couple of word problems as well. So first things first, you should have already started the warm-up. Hopefully that's completed. And so the first one here is we're just trying to find the common difference for D, or a ratio. Remember, common difference, that's for arithmetic, and then ratio we use for geometric sequences for each of these. So if we look at the first one, I notice that I have -5, -2, 1, and 4. I think this one's pretty simple. I'm clearly not multiplying because the common difference is always 3, right? So I'm adding 3 each time, and when I do that, I get each one, so I would say D is then equal to 3. All right, so my handwriting for today is going to be kind of horrible. I'm actually writing on a slate. You might be able to hear me scribbling on this here. It's not the most ideal thing, but you should be able to make out what I got going on. One thing we didn't talk about last class is how to find a common ratio for a sequence. So as I look at this, the difference between 4 and 8 is 4, but obviously the difference between 8 and 16 is not equal to 4. So this is really not going to be it's not going to be arithmetic, obviously. So we got to check and see if it's geometric. And one thing we didn't talk about last class is how to find that. So what you want to do is take the second term and divide it by the previous term. If we do division, we'll find out what multiplication was done. So if I take 8 and I divide it by 4, I get 2. And now if that pattern occurs over and over again, that's what the common ratio is. So if I take 16 divided by 8, I also get 2. If I get 32 divided by 16, I also get 2. So I can confidently say that my common ratio for this geometric sequence is 2. All right, so first two more problems done. Then it says write the first 4 terms of the sequence using the given rule. And so if we look at the first one here, I'm already given the first term. Guys, take the gimme problem, right? The first term is 81. It's given to you. And then remember, what this means is that, again, this is the recursive rule. This is going to be the explicit rule. The recursive rule says that we're going to take the previous term and apply the rule. What's the rule? Multiplying by 1/3. Remember, multiplying by 1 over anything is the same as dividing by that anything, only when 1 is in the numerator, though. So if I take 81 and divide it by 3, I then get 27. If I take 27 divided by 3, I get 9. If I take 9 divided by 3, I get 3. And those are my first 4 terms of the sequence. This one also gives me the value of the first term, so I'm going to write it down and say that it's 8. Then I take the common ratio, which is 3, and I take 8 times 3 to the n minus 1. Well, if I'm finding the second term, 2 minus 1 is 1, and so then 3 to the first power is equal to 3, so 8 times 3 is 24. Okay? And then I'm doing the same thing again. So now I'm finding the 3 minus 1 power. 3 minus 1 is 2, so I take 3 to the second power, which is 9, and 9 times 8 is 72. If I do the same thing one more time, I get 216. All right, so that's how I come up with my sequences for 3 and 4. Okay, so today's lesson is constructing geometric sequences. Last class we talked about those as well, but here we're going to have a little bit more hands-on work to go with it. All right, so as we look through this, these are our rules from last class. A couple things about this. Remember, whenever you're writing these rules, everything that I circle right now are things that you need to fill in. So whenever you're writing a recursive rule, you need to fill in what the first term is here, and you need to fill in what the R value is. Everything else stays the same about the rule. Nothing else changes. You will write f of 1, you will write f of n, and you will write all these other things. The only things that you will fill in are this and this, the value of the first term of the common ratio. Same thing here. The only thing that you will ever fill in for the explicit rule is this number and that number. f of n stays put and n minus 1 stays put. So if we're going to write recursive rules for each of these, an explicit rule for each, the first thing I got to find out is what is the value of my common ratio. What's my common ratio? So I'm going to do the same thing I did before. I'm told that these are geometric, so I'm going to assume that if I take 6 and divide it by 3, well, I do what I do sometimes, and I gave the answer to the problem that I'm doing. 6 divided by 2 equals 3. And then if I take 18 divided by 6, that's equal to 3. If I take 54 divided by 18, I also get 3. So my common ratio is 3. And now I have everything I need to know to write my sequence. My recursive sequence only requires me to know the first term and the common ratio. So what do I write? I say, all right, well, f of 1 is equal to, what I already knew it to be, 2. And then f of n, which is already part of it, is equal to f of n minus 1. Notice that's constant, times the common ratio, which is 3. Okay? And then obviously we could add that to it here, over there, but I don't have enough room here, so I'm not going to write that. For n is greater than or equal to 2. For the explicit rule, I have everything I need to know as well. So we're going to write f of n is equal to, now I will replace f of 1 with what I know it to be. It is 2, the value of the first term. And then r, we already found it, is 3, and then n minus 1 is just part of the rule. So that's the rule that I would use. I would take 3 to whatever power times 2, and I would get the value of that term that I was trying to find. All right, same thing with this one. I'm going to take 28 over 56, and I'm going to try to reduce that fraction first, and it turns out that 28 over 56 is 1/2. And then if I take 14 over 28, I also get 1/2, and obviously 7 divided by 14 is 1/2, so my common ratio here is equal to 1/2. Okay, so now I have what I need to write my general recursive and explicit rules. So f of 1, that's a poor f, but oh well. F of 1 is equal to 56, and my f of n is then going to be equal to, again, f of n minus 1, that's in parentheses, times my common ratio, and this time it's 1/2, so it's fractional. Notice my n value here is less than 1 and greater than 0, so my terms head downhill, right? They get smaller and smaller. For this one, I will do the same thing. I will say, all right, f of n is equal to value of the first term. This time was 56. Common ratio is 1/2, and then to the n minus 1. So very similar to what we were doing with arithmetic sequences, except for now we're multiplying stuff instead of adding. All right? And don't forget, the way you find your common ratio is by dividing two successive terms. The second one, basically the second one divided by the first one, and then the third one divided by the fourth one, and so forth. All right, cool, cool. All right, so now we're going to look at a table and explain what's going on in the table here. So the table shows me that I have my n values. My n value, remember, is the term number. So term number 1 is 1,000, term number 2 is 800, and so forth. And so I have to do the same exact thing. I have to write a recursive and explicit rule for each of these. The first thing I need to do, just like last time, I need to find my common ratio. What is that equal to? And I do it the same exact way I did it before. I'm going to take this term and divide it by that term. So I take 800 divided by 1,000. And if I want to, I can think of it as really 8 over 10, okay, which is 4/5. That's a 5. That's a 4. Geez. Or that is the same thing as saying 0.2. I'm sorry, not 0.2, 0.8. And if I do the same thing with 640 divided by 800, I get 4/5 again, or 0.8. And if I take 512 divided by 640, I get the same exact result, 4/5. So my common ratio, R, is equal to 4/5. And again, I have everything I need to know to write my recursive and explicit rules. So what do? I go ahead and write out my f of 1 is equal to, oh my goodness, it's into the parentheses, but this is a tough spot on the board to write, is 1,000. And then f of n is then equal to the f of n minus 1. Remember, that doesn't change. And then I multiply by my common ratio in this case, which is 4/5 or 0.8. All right. My explicit rule will be f of n is equal to, first term is 1,000 times common ratio of 4/5, or again, you can put 0.8 to the n minus 1. That doesn't necessarily have to be in parentheses. It's the only calculation being done there. All right, so, one further. We have one more on the bottom here. This one, same deal. I have to go through the same exact steps. So I'm going to pause the recording here, and what I want you guys to do is to try this one on your own, and then, please pause this, and then give them like 2 minutes, 3 minutes to work, and then show the answers when. Okay, so you should have gotten your R values to be 3/2 or 1.5 if you keep dividing 3/2 here, obviously, and then 4.5/3 is the same thing. And then your recursive rule should have been f of 1 is equal to 2, and then f of n is equal to f of n minus 1 times 3/2, or 1.5. And then f of n is equal to 2 times 3/2, or 1.5, to the n minus 1. Hopefully that's what you guys got. All right, moving on. So there is a different kind of notation. So it says here, the recursive and explicit rules for a geometric sequence can also be written in a subscript notation. In subscript notation, the subscript, okay, subscript means like if I have x sub 1, the subscript would be that notation. The subscript 1 indicates the position of the term in the sequence. So a sub 1 and a sub 2 and a sub 3 are the first, second, and third terms, respectively, of the sequence. In general, a sub n is the nth term of the sequence. So basically, if I say like f of 1, that's equal to saying like a sub 1 or x sub 1, whatever we use for the variable. In this case, we're going to be using a's, okay? So if I want to write a function rule in recursive function notation, recursive rule would look like f of 1, well, in subscript notation, that would look like a sub 1 is equal to whatever. And then if I want to write instead this f of n, that's going to be a sub n equals, and then on this side of it, f of n minus 1, that means the value of the first term, or I'm sorry, the previous term, so we would just write a sub n minus 1, okay, which this, again, means the same thing, value of the previous term, and I'm going to wrap that in parentheses because I'm going to multiply it by r, okay, for n is greater than or equal to 2. All right? So that's what that looks like. And then the explicit rule is basically the same thing. So my f of n is going to be a sub n, and that's going to be equal to my f of 1, which is a sub 1. I'll put that in parentheses, or actually I'll put my r in parentheses here, to the n minus 1 again. All right, so basically what are we doing? We're swapping out a's with f's, and the 1's and the n's kind of go along with it, okay? So that's what they look like in subscript notation. If you need to rewind the video to have that explained one more time, do that, but I'm going to be moving on here so I don't waste a whole lot of YouTube time. All right, it says write a recursive and explicit rule for the following sequences, but now we're going to use subscript notation. So we have to go through the same exact process that we had before, right? And we have to find our common ratio. So I'm going to take 75 divided by 375, okay? And that is going to give me 1/5, which is also equal to 0.2. Then I'll take 15 over 75, and that's also equal to 1/5. And if I take 15 over, 3 over 15, that is also equal to 1/5. So my R value here is 1/5. Okay, So how do I write my recursive rule now in this notation? My recursive rule, instead of writing f of 1, I will write now a sub 1, and that's going to be equal to the 375. And then instead of f of n, I will write a sub n, and that is going to be equal to, put this in parentheses, a sub n minus 1, a sub n minus 1, and then times the 1/5, or point, I wrote 1/2, my bad. 1/5. And so there is the recursive rule. Okay, explicit rule, I would have a sub n, the value of the term I'm trying to find, is equal to 375, that's my a sub 1, times the 1/5, and then to the n minus 1. Okay, same thing for this one. I'm going to have you guys try this. So go ahead and pause the video. And when you come back, I want to see if you guys can get this one done. So substitute, please pause the video. Okay, what you should have gotten for your common ratio, you should have gotten R is equal to 3 when you did your divisions. Obviously, 30 divided by 10 is 3, 9 divided by 30 is 3. And then your recursive sequence should have started with a sub 1 equals 10, and then the value of any term, a sub n, is equal to a sub n minus 1 times 3. Then your explicit rule is going to be a sub n, value of any term, is equal to 10, value of the first term, times your common ratio of 3 to the n minus 1. Hopefully you guys got that. If you need that re-explained again, go ahead and back up the video. Okay, now, this is going to take a little bit of time to explain. It says the fifth term of the sequence is 45. All right, so I'm just going to write that down. A sub 5 is equal to 45. Then it says the seventh term of the sequence is 5. I'm going to write that down. A sub 7 is equal to 5. It says write a recursive and an explicit rule in subscript notation to represent this situation. Okay, now, what are we missing? Previously, what did we do? We said, well, I have all these, oops, I think I went a little bit too far there. I have all of these numbers in order, so all I did was divide sequential numbers to figure out the common ratio, but I'm skipping numbers, right? I have the fifth and the seventh term. I don't know what the sixth term is, right? It's a big question mark. I don't know what it is. So here's how you do it. The book explains it in one way. I think this way explains that a little bit better. So I have 3 terms in order here, right? I have my a sub 5 term, my fifth term, and I have my a sub 7th term, and I don't know what this is. And this term here is 45. This term here is a blank, I don't know what that is. And this term here is 5, okay? So here's one way to think about this. What are we doing? Well, I'm taking 45 and I'm multiplying by something, which is r, right, to get the sixth term. And then to get to the sixth term to the seventh term, I'm multiplying by r again. Well, what am I really doing? I'm saying that 45 times r is equal to 5, aren't I? I can come up with the equation for that. 45 times r is equal to 5. Great. Well, I can simplify this and say 45 times r squared is equal to 5. And I can simplify this even further and solve for r. What do I got to do? I got to divide both sides by 45. And that's going to give me, r squared is equal to 5 over 45 reduces down to 1/9. Okay. And now I have r squared is equal to 1/9, so what do I have to do? I have to square root both sides. So I got r squared, I'm sorry, no longer r squared, I have r is equal to the square root of 1/9. Now let's take a step back. I'm going to erase this here. What is square root really? Square root is to the 1/2 power. So I know that I can take, I can take 1/9 to the 1/2 power. Well, what does the exponent rule say? Multiply each of those. So what do I really have? I have 1 to the 1/2 over 9 to the 1/2. And what is 1/2 really? 1/2 is square root. So I have the square root of 1 over the square root of 9. So what do I really have? I have 1/3. Okay? So it's not too much of a leap to go from here to here, right? If I take the square root of a fraction, what am I really doing? I'm taking the square root of the top and the square root of the bottom, all right? That's what I got going on here. So I end up with 1/3. So let me get rid of all of that stuff quickly, because our common ratio, oh, that does not please me. Okay, hold on. Erase, erase. All right. So my common ratio, what do we say it was? And all the people said 1/3, right? Holy buckets, that's not what I want. Okay, bear with me, technical difficulties. 1/3, right? 3. Why aren't you writing 3? Hold on here. All right, some technical difficulties there, but what we came up with is 1/3 for our common ratio. Okay, so now that I have my common ratio, what do I need to write my recursive rule? I need a sub 1 yet, and I don't have it. So what do I need to do is set up the formula for solving for a sub 1. All right, so what would that be? If I were to write this out, I know my a sub 1, I know a sub 5 is equal to 45. So what I can say is if I were to use my, say, explicit formula, I could say that 45, the value of a sub 5, is equal to the value of the first term, which I don't know, times the common ratio, which I now do know, to the, and what would this be? N minus 1, right? Well, my n value at this point is 5, so I'm going to use 4 as my exponent. So now I know how to use these exponent rules. This says 45 is equal to a sub 1. 1 to the 4th power is 1, and 3 to the 4th power is 81. And now I multiply both sides by 81, which sounds crazy, but that'll give me my first term. 81 times 45 is 3,645. That is my first term. So now I can go ahead and write my recursive series. 3,645 is my first term, and then a sub n is equal to the previous term, so we call it a sub n minus 1 times that common difference of 1/3. If I was going to write an explicit rule now, it would be a sub n, which is equal to that first term we just found, 3,645, times my common ratio, which is 1/3, to the n minus 1. Okay, so let's take a step back here and think about the things that we did. How did I find my common ratio? I said, well, the 5th term was 45. I don't know the 6th term, and the 7th term is 5. Well, how do I get from the 5th to the 7th? I have to apply the common ratio 2 times. So I said 45 times r equals 5. 45 r squared equals 5, and I solved that to get 1/3. Then I used what would be my explicit rule, right? And I solved for a sub 1 using a sub 5. A sub 5 was 45. That was equal to a sub 1, what I didn't know, times my common ratio of 1/3 to the 5 minus 1, which is 4. And I just solved that for a sub 1. So let's see how that all comes together here in the next word problem. Okay, so this is the last one of the day. We're almost done here. So again, if you need to pause anything, it's no big deal. It says, Michael tells a number of his friends about an interesting video he saw on YouTube. Each of his friends tells the same number of friends about it. This pattern continues, and there are no reads in the people told. The number who people hear the video through Michael's forms a geometric sequence. There are 256 people at the 4th round, and there are 4,096 people at the 6th round. Write a recursive and explicit rule in subscript notation to represent the situation. Okay, we have the same type of problem. I know that my a sub 4, the fourth round of this, is equal to 256. I know that the sixth round of this, a sub 6, is equal to 4,096. How do I find a sub 5? Well, remember, in order to go from one to the next, I have to apply that rule. I have to multiply by my common ratio. How many times am I doing it? To go from a sub 4 to a sub 5, I multiply by 1 once, multiply by the ratio once. If I go from a sub 5 to a sub 6, I multiply by the ratio again. So, what does that mean? That means that 256 times r is equal to 4,096. Or 256 times r squared is equal to 4,096. Okay, now, just like before, I'm going to divide by 256, both sides. Again, apologize for my handwriting. That gives me r squared is equal to, when I divide that by 256, I get 16. So then the square root of each, this one's much easier than taking the square root of 1/9. The square root of 16, r is just equal to 4. Okay, so now I found my common difference. Lowercase r is equal to 4. All right, so now I got to find my first term. So again, I'm going to start off by writing what would be my explicit rule. And so I'm going to use my a sub 4 value. So a sub 4 was 256, right? 256. So I will say then 256 is equal to my common ratio, or I'm sorry, a sub 1. That's what I'm trying to find. 256 times 256 equals the value of my first term, which I don't know, I'm trying to find, times the common ratio, which I just found, to the n minus 1. If I'm using a sub 4, my n is 4, so then 4 minus 1 is 3. Okay, so then I get 256 is equal to a sub 1. 4 to the third power is 64. And if I take, so this is multiplied together, and if I divide both sides by 64, I get 4 is equal to a sub 1. So now I have everything to write my formula. I have my first value, and I have my common ratio. So a sub 1, just found, is equal to 4. A sub n is then equal to a sub n minus 1 times the common ratio of 4. Again, that is 4, n is greater than or equal to 2. And for the explicit rule, I write a sub n, the value of any term, is equal to the value of the first term, which we just found out to be 4, times the common ratio, which is also 4, it's a coincidence here, to the n minus 1. Okay, now this video is going to be posted on the Moodle page. So if there are things that you want to go and watch again, go back there and watch it anytime. Watch it for fun. Share it with your friends. Share it with your parents. It'll be great. Your homework tonight is going to be these problems here. It is also listed on the bottom of your activity. Sorry, not your activity, but your notes for today. I hope that you guys have a great weekend. I will see you when I return. Peace. Peace.